Hey class, welcome to 1.6, which is all about graphing. That means that I can interpret graphs, I can make a graph. And so we're going to talk today about the different parts of a graph, as well as the kind of trends that we are going to be looking for when we graph data. Because in this class, as we start graphing, that's exactly what we're looking for. We're looking to see, is there an actual relationship between X and Y? If there's not, that's okay. Or if there is, what type of relationship is it? How do the two variables affect each other? So when talking about a graph consists of two parts. It consists of an independent and a dependent variable that sit on those X and Y axes. So these two variables, like I said, so we have two variables when it comes to graph. We have independent and dependent. So let's talk about what each one is. So we're going to start with our independent variable. An independent variable is what we are changing, or what we change. And it goes on the x-axis, so it sits on the bottom of the graph. And so just for reference, we're going to draw a little graph up here. And we're going to make sure we know that this is the x, this is the y. There's a z-axis to make it three-dimensional. We don't have to worry about that. So don't get too big for me here. Now, our second is the dependent variable. And in a dependent variable, it is what is being measured. So for instance, if we are trying to find the relationship between, let's say, how fast someone is and how tall they are. Well, I'm measuring their speed and I'm changing the height of people in who I'm measuring, and we're going to try and find that relationship. So the height would be independent, the speed would be dependent. And that sits, of course, on the other axis, the y. Now, most of the time we're going to use something called a scatter plot. And a scatter plot is where you take our data, you put it all on the chart, and then we try and find what's called a line of best fit. And all of those things are important. So on a scatter plot, so let's make sure we, again, recognize what a scatter plot is, because that's what we're going to use the majority of the time in this class, is the data is not going to perfectly line up. So you're not going to get a perfectly straight line. And that's for a lot of error reasons. That could be your measurement tool isn't perfect, human reaction time. And I want to be very clear, when we do experiments, there's one type of error we don't talk about, and that is human error, which is kind of this catch-all phrase for what we did wrong. And so when we do that, we want to be very specific about that error. So notice I didn't say human error, I said human reaction time. Our tool was incorrect. Maybe I was slowing down when I should have been trying to run at a consistent pace, because it's hard for humans to do that. Again, human error is just kind of this catch-all term that we want to kind of avoid. So that's why you don't get a perfectly even lineup. And so what we do instead is we try for a line of best fit. And a line of best fit simply follows the trend. So a couple of graphing examples that we're going to go through are the types of relationships we're going to look for. And so for instance, let's quickly get an example of our scatter plot here. So here's that graph, x and y axes, right? There's our x, there's our y. The graph might have a lot of lines or dots that look like this. Notice they're generally going up and to the right. And so I might create a line that is doing that. And so we have a general trend, but it doesn't connect the dots. That's kind of the thing we're avoiding. We are avoiding connecting dots, which is something we're very tempted to do. So let's talk about the relationships. So there are 6 relationships that we're going to be looking at. So let's talk about what those are. So the types of relationships. So types of relationships, like I said, there's going to be 6. So let's create ourselves 6 graphs here. 1, 2, 3. 3. All right. So we have 6 types of relationship. We're going to draw them out. So the first is a direct relationship. That's kind of what we drew earlier, where the lines kind of follow a general up. This is called a direct relationship. It means as one increases evenly, so does the other one. If the force doubles, then the acceleration doubles. That's kind of what we're looking at there. That's a direct relationship. The next is an inverse relationship, which is a opposite of a direct relationship. So instead of the data going up and to the right, it goes down and to the right. After that, we have a squared or an exponential relationship. So exponential. An exponential relationship is where it starts off kind of flat, but then it increasingly gets bigger. So it's a curved up. You've probably seen this, we know this as a parabola from your math class. So that's exponential. Then we have what's called a logarithmic relationship. A logarithmic relationship starts off kind of like a parabola. It's kind of the flip of it. So it starts off straight, but then it flattens itself out. And it's modeled after the log function on your calculator, which some of you may know and some of you may not. It's kind of a rare function we won't really touch, but the relationship is important to know about. Then we have a 1 over x relationship. This is where we start off on a steep decline and then we kind of zero out along the axes. Along the x and y, we kind of have these lines like this. And so that is it never touches either of the axes, it just kind of runs alongside of them. It's 1 over x. And then lastly, we have what is known as no relationship. So it's kind of false to call it a relationship, but it's saying that the two things aren't related to one another. So if I tried to graph the temperature outside versus versus the printing, how many pages of paper get printed every day here, like that's not, those don't relate in any way. Who knows, we might find a relationship, but probably not, because they don't affect each other. And so it just means, hey, whatever you're looking for, it's not there. And so we have these 6 types of relationships. What you're going to do in class is that you are going to try and find the correlation between some data that you're given. You're going to have almost every type of graph on there, and it's just important that we know, one, how to graph. And we talked up here earlier on what graphs look like. We have our variables on the x and y axes. We talked about the types of relationships. Now, the last thing we want to do is something called scaling. So scaling is something that a lot of students struggle with. And so, and scaling, that's how we spell it there. But we're actually going to flip our background here to make it into an actual graph. So we're going to flip this. And so for scaling, it's all about how we use the space of our graph. And so I'm going to draw a graph here that's 10 lines long on both sides. So 3, 6, 7, 8, 9, 10. All right, so here's my graph. Ooh, did one too many over here. That's okay. And so if I have some data, let's just say we're gonna make up some x and y data here. So on the x, we're gonna have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pretty straightforward data there. But in the y, instead of that, we're going to have some different data. It's gonna look slightly different here. Where And if you're like, oh, Mr. Clare, I see what you're doing. You're making a pattern of 1 and 3. Yes, but we got to talk about how we scale this graph. So I've got 10 lines along my x-axis, and that one's easy, right? I might just label them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Easy. But along the y-axis, I have to change my scale. So I've got 10 lines that I have to use. I have to use the majority of them. And I've got 30. So I would make my top number 30, and then I got to think to myself, ooh, okay, how do I scale this down? Well, I've got 10 lines. So what I will do is I'm going to take my largest number here. I'm going to take 30. I'm going to divide it by 10, and it gets me 3, which tells me that every line should be 3 less. And if that works out, then I should be all the way down to perfect. However, sometimes our data isn't exactly what we want it to be. So we don't have this clean, 10 and 10 that we've talked about. So let's try again here. Let's make one more graph. So 10 and 10. And instead, we're going to have kind of some more kind of seemingly random data here, where on the x-axis, we're going to have 3, 7, 12, 14, and 23. And on the y-axis, we're going to have 100, then we'll have 72, 43, 23, 9. And so the question here is, okay, so how do I scale? So let's take this one at a time. So I'm going to take my x-axis first. My x has a maximum of 23. And I've got 10 lines, and I know that a good deviation of each line would be about, some multiple of 10. So I might go to the next multiple of 10 and say, well, 30 is the upper one. So I'm going to make my scale 30. And then we know every 3, like we did earlier. I'm going to kind of shorten it here and do every 2 lines. So that'd be 24, 18, 12, 6, 0. Oh, I had my lines 1 too long there. But essentially what we're doing, guys, is we are figuring out that, hey, I don't need to, I need to use my graph, but I don't need to try and squeeze it really tightly. Well, then on the other end, well, my top number is 100. And so that would tell me, hey, I need to go by 10s in that direction, starting at 100 max. And how do I fit that? Well, I would go by 10s, and I'm skipping lines here to show you. So we need to use the majority of our graph when scaling. And basically, you look at the top number and say, how can I make sure that that fits on the graph? What would not be good if I took my 100 and put it down here? Well, because then I'm only using this much of the graph, and that's not usable. I need to use all of it. So talking about scaling, it just means we need to actually use the graph appropriately. So graphing is important. We're going to do a ton of work on graphing this year. It's going to be almost every unit, every lab, we're going to have some kind of graph that we are doing to represent our data. So be ready. You got a worksheet to work on today that will give you more practice with scaling, assigning variables, and then finding relationships, all of this. So if you need help, please come ask. I'm always happy to help you guys.